When a new AI feature drops in a game you love, it sounds like marketing fluff. But Fortnite's shift to dynamic personas reveals a brutal engineering reality that generic tutorials ignore. This isn't about cooler NPCs, it is an architectural stress test for real-time inference at scale. While developers learn to build models in isolation, they often fail when facing sub-50 millisecond latency requirements and the true cost of compute per token. Today, we connect this headline to the specific bottlenecks that break production systems, not just demo environments. The narrative that Fortnite is getting AI avatars sounds like standard pop culture news, but the engineering reality inside those game sessions reveals a critical failure point for most developers. You might assume that because large language models can generate text or code instantly, they can power real-time interactions without friction. This assumption is dangerous. The time taken to process input and return output, even by mere milliseconds, breaks the user experience in live systems like gaming, where every frame counts. Look at what happens when you try to force this technology into existing infrastructure using open-source attempts. Consider the repository MistyFN. It was explicitly discontinued by its creator due to a lack of profitability and an inability to sustain development against commercial game security measures. The data tells the story. It holds 0 stars, indicating zero community adoption or validation as a scalable solution. A forked version attempted to use local AI for aimbot functionality, but relied on heavy dependencies like Python 328 and specific NVIDIA drivers just to run at all. These projects demonstrate that attempting to run complex generative models locally creates what we call the latency trap. The overhead required for driver management, memory allocation, and script execution is incompatible with the strict frame time budgets of live multiplayer games without massive optimization. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to a second critical bottleneck: visual reasoning. Projects like Scrimbrain prove that training an AI to interpret raw pixel data rather than structured game variables requires significant computational resources, even on a single consumer GPU. To achieve functional visual reasoning in these experiments, the model must process 1920 by 1080 resolution at 60 Hz with VSync enabled and low texture settings just to maintain basic functionality. This mirrors the challenge of dynamic avatars perfectly. If an AI must interpret raw video frames in real time, it hits a hard wall on latency. The experiment shows that without privileged API access or massive server farms, you cannot simply swap static assets for dynamic inference without sacrificing performance or visual fidelity. The official integration gap further clarifies the engineering landscape. While some explorations exist into integrating generative AI into development tooling via scripting languages like Verse, these rely on external trial services and have minimal traction with only 3 stars recorded. These represent early-stage experiments in code generation rather than a live, scalable inference engine for player avatars that would require sub-second response times across millions of concurrent users. The shift from static assets to dynamic model serving is not just a cool feature. It is an architectural stress test that exposes why 90% of generic AI deployments fail in live, concurrent environments. The discontinuation of MistyFN isn't a failure of the underlying artificial intelligence technology itself. It is the collapse of an architecture that could not justify its compute cost against real-world latency requirements. When you build for accuracy without considering throughput, you end up with a system that works on your laptop but fails in production. Developers are building for model performance when the market demands infrastructure efficiency. The winners will be those who solve for latency and cost per token, not just capability scores on a benchmark leaderboard. This distinction is vital for career relevance right now. You need to know how to architect systems that handle these strict constraints, not just write prompts or train models in isolation. The skill gap is shifting from model selection to system design. Knowing which GPU architecture enables inference at scale and understanding the trade-offs between local execution versus cloud serving are becoming more valuable than knowing the latest prompt engineering tricks. If you cannot balance compute costs against user experience when the clock is ticking on every frame, your application will not survive launch day. Scrimbrain proves you can train visual reasoning on consumer hardware, but only if you accept massive compromises in resolution and frame rate. A trade-off most production systems simply cannot afford without dedicated AI accelerators or optimized inference engines. The lesson here extends far beyond gaming. Any system requiring real-time interaction, from customer support bots to autonomous vehicle perception stacks, faces this same equation of latency versus cost. The takeaway is clear. Artificial intelligence is not a magic button that solves engineering problems instantly. It introduces complex infrastructure challenges regarding memory bandwidth, token processing speed, and concurrent user load management. As you move forward in your career or projects, prioritize understanding the constraints of real-time deployment over theoretical model capabilities. The future belongs to engineers who can deliver dynamic experiences without breaking the frame rate. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.